How to wire an arcade control panel with LED buttons.
This will be a two-part or maybe a three-part video on how to wire and configure an arcade control panel. This video will focus on how to wire a custom arcade control panel with RGB LED buttons and the Ultimarc Ultimate I/O interface board. LED stands for light emitting diode, and RGB means it can display red, green, blue, or any combination of the three. So these buttons should be able to change any color except brown or black. Wiring a control panel isn't too complicated. However, wiring LEDs to each button and the joystick make it a little bit more difficult. It is a pretty repetitive task, so I'll be playing this video at fast speed most of the time. Like usual, I have timestamps in the video descriptions if you want to skip ahead. Wiring is an art, and I'm probably a step above a hack. I'm not wiring for an airplane or a car, so as long as the wires don't snag on the buttons, snag on the joystick, or when the control panel is closed, then I'd call it a success. At this point, I don't know how to configure the LED board, and we'll make a video on how to do that for the Raspberry Pi and a PC. First things first.
First things first!
Let's talk about the control panel you see. What you're looking at right now is a customer request for a custom control panel with 4 players and 8 buttons in the middle. Most arcade games had 6 buttons, with the exception of Neo Geo, which apparently had 7. I say apparently because I've never played any of those titles. Newer games like Street Fighter V use this 8-button layout. The customer said he wanted to get a custom paint job, so he saved money by having this shipped unfinished like you see it here today. This control panel can come fully configured or in a kit. It can be attached to a replica or original Konami 4-player arcade machine, or put on a coffee table and hooked up to your living room TV. If you buy a Bearwood kit, it will look similar to this one with the T-molding slot cut out and a little bit of sanding and filling required before paint. Let's move on to the tools for the job. The first tool isn't required, but it makes the job of verifying the wires a lot easier, and it's my multimeter, or multimeter, or however you want to say it. You'll see me use this in continuity mode to check connections. I think I bought this from Sears when I was like 16.
Multimeter.
I have a little screwdriver, also known as a tweaker. And here are a couple types of strippers. Come to think of it, electrical tools have a lot of funny names. You also may need a pair of dikes, as they're good to have around.
Phrasing?
I know what you're thinking, dike. Like the little Dutch boy who stuck his finger in a dike. It's not the same. This tool is spelled different. There are a couple of options for connecting wires, to crimp them or solder them. Here's a couple types of crimpers. No funny names for these tools.
But I feel like such a tool!
And here's my soldering iron. I like this one because it is ESD safe, meaning it won't make a static electricity spark and short out sensitive electronics. And it's made in Malaysia instead of China like everything else. So that's pretty much it for the tools required to wire a control panel. Now I'll get into the types of buttons and controllers. This is an LED joystick. The ball lights up and it has 4 unterminated wires for the light coming out of the base of the shaft.
Phrasing.
Here's a Chinese-style Zippy controller. I think all of the controllers are made in China, but this one seems to be especially low quality. Sometimes the restrictor plates on the back need to be removed in order for it to function properly. They do have this ball top, which is more like the original equipment for a Konami 4-player panel. Here's a Hap-style or Industrious Lorenzo controller. And a solid color Hap button. This is what the assembled LED button looks like. It's a clear Hap-style button with a little LED board hanging off of the side. With LED buttons, the control board connects with the DuPont 0.1 inch or 2.54 spaced connector. You can use wires like this to connect it, and I have a wire with male-female connections. Don't get the male-male because it won't work for this. And as much as you like the sound of the wires with female to female connection, they aren't the best choice either.
Oh, we're just done with phrasing, right? That's not a thing anymore?
These big bundle of wires came with the LED boards. And here's the board I'll be using today. It's the Ultimarc Ultimate I/O board. That's a bit of a mouthful. On the left and right, it has connections for the LEDs, and there's 36 of them. The player 1 inputs are on the bottom, as well as the player 2, and along the top are players 3 and 4, with 4 buttons for player 3 and 4. This will apparently connect a trackball and a spinner also. This board has a separate connector to power the LEDs, and it assumes you'll have an open connector on your computer power supply. I don't have a computer power supply, so I had to buy this 5-volt power adapter. The instructions say you'll want 0.02 amps per LED, and I have way more than enough here. Now you see me buzzing out the end of the connector for the power supply with my multimeter to make sure they match. I wanted to make sure the center conductor and the negative were in the same orientation, and they are. This is my first time using this board, as I mentioned before. I usually connect with an ipac 2, or if I need more connections, an ipac 4. These have terminal blocks, so you don't have to worry about getting the right crimper or contacts, or the correct wire size to go into the crimper and contacts. There are other styles of input boards I've used. Some are pretty crappy and arrive dead on arrival. Others are more cheap than the Ultimarc versions, and they seem to work okay. I personally like to use the better products so I don't receive email and phone calls about non-functioning machines. If you're using a DuPont connector like I am, you can either solder or crimp the wires. If crimping, you'll need to get some female contacts. Make sure they fit the wire you want to use and find the right crimper. I bought mine on the internet for like $25. So they make a harness to connect the player 1 and 2 controls on this board, and it costs about $20. I'd recommend springing to get that one so you don't have to crimp so many connectors. They also make a player 3 and a 4 harness, and those ones are $14 a piece.
Good Lord, that's a lot of money.
I don't recommend that one because it's $30 just for a very few amount of crimps. So either way, you're going to want to know how to either solder or crimp together these connectors. Here are the wires I like to use for connecting buttons. It's a 16 gauge wire that has a quick disconnect or spade connector on one end, and it's unterminated at the other end.
Yeah. I cannot self-terminate.
You can also buy a daisy chained ground wire that looks like this, because all the grounds should be connected. That's about it for the hardware. Now I'll get into how to mount the controls to the panel. The panel comes with pre-drilled holes for the controls I mentioned before. I install a brass insert so we don't have any of those unsightly fasteners going through the panel like in the original. Here I am marking the spots for the control I'm using since the panel has 4 holes. You see these controls line up like intended in the hole pattern. This brass insert is for a 1024 fastener. What you want to do is choose the correct tool to install the insert. You don't want a lot of slop when turning it. This one fits a number 5 tool, which is metric and not US like everything else on this. Installing the inserts is pretty easy. You want to install them just below the surface and not bust through the end of the panel. And if you do bust through the end of the panel, it can be patched up. So you just make sure you're putting them in straight. And after they're installed, the hole may be volcanoed or raised up around the edges a little, so you'll want to hit it with some sandpaper and make sure you don't see any shiny metal. If you do see shiny metal, the insert's a little high. If for some crazy reason you don't own an impact driver, like burglars broke in and stole yours, or you dropped it off of the roof, then you can do a hand job with this regular old Allen wrench. Same idea as before. Now we'll hit it with some sandpaper. And after they're all installed, you can see I have one that didn't go deep enough. It's shiny and sticking up. I'll give it another turn. Not too shabby. No holes or bumps on the other side of the panel either. Now, one more thing before installing the controls is to select the right fastener length. 2 of the 3 joysticks I show you had different thicknesses, and you don't want the fastener to poke through on the other side. This is what too many threads sticking out looks like. And this is what a good fastener looks like. It barely pops out of the top, which is okay, because the hole is a little deeper and I'll be using a washer. So this fastener is a 1024 by 5/8 or 0.625 inches long. The HAP style controller will take a 7/8 grip length fastener. I'm not using the HAP controller today, so I'll go with the 0.625 grip length. So here I am installing the fasteners finger tight into the joysticks. If you install 1 or 2 of them and then tighten them, the others may not go in, and that's the only real trick that there is to installing these joysticks. And then you screw the joystick ball back on without damaging the LED. And see, no bump on the other side. So now those are installed. And onto the buttons. All you have to do is unscrew this little collar, install them, and then put them in. The same task about 30 times. Since this is an LED, you have this little board to slide over the button. And then you install the micro switch on top of that. To wire the button or the joystick, you put the negative on the bottom and the positive on top. The other switch is if you want to have the connection interrupted when the button is pressed. In our case, when the button is pressed, that's when you want the connection to be made. If I were using a key encoder with a terminal, I would just strip my wire and put it wherever the terminal goes to that button. So for instance, player 1, button 1. And all the negatives would tie together with this daisy chain harness. And they would all go to the ground terminal like so. In our case, we have these DuPont connectors, so we either need to solder or crimp the connection. Soldering can be done if you don't have the contacts or if you just want to join 2 wires together. Here's the male-female DuPont connector. Here's our LED harness, and it goes with the red, blue, green wiring lined up with the RGB on the board. At this point, I'm going to choose an area to mount my encoder. You want to choose an area that's out of the way so the joysticks don't interfere with it. I loosely install these feet and make sure I'm not putting a load when I'm tightening the fastener down. So you can see here I'm trying to figure out what length of screw to use. 1 inch is too much, it would stick out of the other side. Less than 1 inch is good. I don't recommend buying sheet metal screws, although they still will work. Now my board is mounted and I can start routing the wires to it. So I'll start with the ground connectors. They all get connected to the bottom of the switch. When connecting these spade connectors, you can sometimes accidentally connect them between the plastic and the connector. You ought to feel if that happens. It's kind of hard for me to pick that up on the camera. I like to attach them with the flat side down so I can see if they're installed correctly. There aren't enough connectors on my daisy chain harness, so I'll solder them together later. And here I am clipping the end off and removing the insulation from the end in preparation for a solder later. So here's how I'm going to crimp the input connectors. And I have this electrical crimper for the job and some special contacts. So the first thing you do is strip the wire to the correct length. So in this case, the center conductor would stick out of the back. It's a little bit too long. I'll snip the end off, and then I line it up with my stripper to see how much I should be removing. This is actually the first crimp of this type I've ever made. These components are pretty small, and the conductor only goes in one way. It's hard to pick this up on the camera, but when you're done, it should look something like this. I do a pull test to make sure it doesn't want to come out, then just press the connector into the housing. I do a continuity check here just to make sure my connection is good, and it is. So this is how you would solder the connector if I was to go this method. I get out my handy dandy soldering iron and my helping hands. And I'm using again a male to female connection. And I heat the back of the connection up. I put a little bit of solder on the solder tip just to get it flowing. And then once it starts flowing, it gets sucked up into the wire. I tape the wires together so there's no load on my solder connection so it doesn't break free over time. So now I take this party inside because it's difficult for me to wire with the camera in the way as it is. I like to color match the wires to each joystick or button bank to make it easier to tell the difference. Off camera I crimped about 46 connectors and they're ready to install. And here's another view of me crimping one of the ends on. You strip the end of the right length, twist the wires, load in a contact and cinch it down so it stays. And then you want to feed the wire in just so the insulation is inside the crimper. You give it a squeeze and that's it. And you can see one end has the spade and one end has the DuPont.
A few moments later.
Here they are all connected. It looks like a complete bird's nest. I opened the panel so I could see which direction I want to route the wiring and make sure I have a nice service loop. Now that it's opened up, I'm going to start connecting and routing all the wiring, one player at a time. I have to connect the wires to their correct location. In this case, I'm going to make the middle joysticks players 1 and 2, and the ones on the end player 3 and 4. I did this because of the way the board is set up. I went ahead and connected all the LED harnesses because I wanted to make sure I wasn't going to route over them and make it difficult to connect them later. It makes it even more of a bird's nest than normal. And when I'm done wiring a joystick or button bank, I group all the wires together and make a nice loop with the extra wire length. So here I push it into the correct location on the connector. I have my multimeter out to verify I have the correct wire going to the correct location. It's easy to mix the up and down, left, right when the panel is upside down. Here's what it looks like when the players 4 and 1 are wired up. So repeat with the other wiring, connect them in a group, tape them together, and leave a nice loop for the panel to close. Now that all the joysticks and buttons are connected, I start connecting the LEDs. And the LEDs come with a heck of a lot of wire length, which is good because it means you don't have to splice things together as much. And so this is what a mostly finished product looks like. I say it's mostly finished because I have 36 connections and 34 LED areas, so I'm going to need to splice in the player 1 and the coin button. Also, I didn't solder splice all my ground connections together, but I did show you how to do that earlier today. Here's an example of a board that doesn't have LEDs and uses the terminal style connection interface that I like to use. It's a lot cleaner, it's easier to wire, and you get the picture. I mean, if you want to wire this one, it's the same process as before, just not with the LEDs. I connected the board to see what happens, and only 2 lights turned on. But then when I connected it to a computer, I got this sweet light show. Originally, I had connected the harness to the right-hand side incorrectly, which isn't a big deal. I did remove and add the connectors on the LEDs so it would light up in the order that you see. You can see I don't have the joysticks or the coins connected because I need to make a splice there, and I want to figure out how to use this board before I finalize all my connections. Oh yeah, I have this manual from the Adafruit website. It's NeoPixel Oberguide. And I'm interested in learning how to wire my own LEDs since this is a pretty expensive option. I got this bank of 100 LEDs from China, and I'm curious to see how they work. That's going to be one for much later down the road since I'm using up most of my time making custom control panels like this one. Here are my final thoughts on this board. I don't like the DuPont style connector as much as the terminal block connector. The player 1 and 2 connector is pretty tight, and connectors exist so you can remove them. But if it fits so tight, I wouldn't recommend messing with it. I also don't like that the player 3 and 4 harnesses are so expensive. Wiring is an art, and a much nicer way of doing this task is to route the wires, cut them to length, and then terminate the wires. Same thing with the LED harness. You can see the difference in the complexity it adds and the extra wiring that sits in the control panel. In the future, I'd like to purchase an automatic style cable crimper to install the contacts and make my own custom harnesses. But for now, this method works pretty well. This video turned out to be longer than I thought it would be, but I spent a lot of time talking about the different options and tools for wiring the control panel. So I hope this video was helpful for you to understand how to wire an arcade control panel. It's pretty low difficulty, especially if you're using a terminal type board or pre-crimped harnesses. No matter what you use, you'll likely be splicing a couple wires or misconnect some of the switches, and it's not a big deal if you do. So that's about it. I will continue this series later when I show you how to configure this particular board. The instructions on the internet are not so good. I intend to make a machine that will tell the board to light up and change colors on the buttons that are in use. So for instance, if you're playing Pac-Man, only the joystick will light up. Or if you're playing Ninja Turtles, you get 2 buttons and a joystick per player. It sounds like a pretty sweet option. Thanks for watching.
Thank you for watching, Flesh Creature. Now get back to work.
Ah!